Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for students of class 12 of CBSE. The first problem goes like this. Solve dy by dx is equal to x plus 7y by x, given that y is equal to 1 when x equal to 2. This is what is given to you. When such a condition is given, I mean to say, I am supposed to find the particular solution. If the answer is given in terms of c, which is the constant of integration after integrating the whole lot, that is called general solution. If you are given a particular condition like this, when x equal to something, y equal to something, etc., it will give you a particular value for the constant c. Such a solution is called particular solution. Just see how we go about the answer. This is the question, solve. Now listen, dy by dx is equal to x plus 7y by x. I call it as 1. Let f of x comma y is equal to x plus 7y by x. I take the right hand side as f of x comma y. Let me try to simplify f of lambda x comma lambda y. Lambda x plus 7 lambda y by lambda x. Lambda into x plus 7y by lambda x, which will be equal to lambda power 0 into f of x comma y. Lambda will get cancelled. Therefore, when such a case arises, I mean to say f of x comma y is a homogeneous function of degree 0. Homogeneity means each and every term is of same degree. Power is 1, power is 1, power is 1. Instead of observing that way, we are doing this way. If I am able to get the right hand side as f, prove the right hand side as f of lambda x comma lambda y is equal to lambda power 0 into f of x comma y. In such cases, we say the right hand side is a homogeneous function of degree 0. In such cases, I mean to say 1 is a homogeneous differential equation. This is the meaning. If you are given dy by dx equal to some f of x comma y, which is homogeneous, I'll use the substitution y is equal to vx. If it is the form dx by dy equal to some homogeneous function on the right hand side, I put x equal to vy. Remember carefully. Therefore, dy by dx will become v plus x dv by dx. V into 1 plus x into dv by dx by product rule of differentiation. Therefore, 1 will now become v plus x dv by dx to be is equal to x plus 7vx by x, which is equal to 1 plus 7v, which implies x dv by dx happens to be 1 plus 6v, which implies integral dv by 1 plus 6v is equal to integral dx by x. Just multiply and divide by 6 here. 6 dv by 1 plus 6v is equal to log mod x plus log c, which implies 1 by 6 log 1 plus 6v. The derivative denominator is there in the numerator. In such cases, we will write log of the denominator. The right hand side becomes log xc, which will imply you log 1 plus 6v whole power 1 by 6 is equal to log xc. You should not cancel log, just equate the values. Therefore, 1 plus 6 y by x whole power 1 by 6 is equal to xc is the required general solution. Is the required general solution. If you leave c as it is, that is called general solution. Now, when y is equal to 1, x equal to 2, or x equal to 2, y equal to 1, either way you can write. Now, for I mean to say here 1 plus 6 into 1 by 2 is equal to 2c, is equal to 2c, whole power 1 by 6, sorry. This will imply you c happens to be 4 power 1 by 6 by 2. Therefore, 1 plus 6y by x whole power 1 by 6 is equal to 4 power 1 by 6 by 2 times c times x is the required, this is called the particular solution. This is the required particular solution. This is the required particular solution. I repeat the whole process. Just listen carefully. This is the question given to you. I name it as 1. I'll take the right hand side as f of x more is equal to this much. I'll replace x by lambda x, y by lambda y. Here lambda gets cancelled. Now for f of lambda x comma lambda y becomes lambda power 0 into f of x more y. In such cases, I mean to say f of x more is a homogeneous function of degree 0. Now, whenever the right hand side is a homogeneous function of degree 0, the whole differential equation is considered to be a homogeneous differential equation. Whenever it's the form dy by dx equal to function of x comma y, I'll use the substitution y is equal to vx. Whenever dx by dy equal to function of x y, which is homogeneous in the right hand side, we mean to say we put vx equal to vy. The very idea of this substitution is after some stages I'll be able to split the variables v's and x's, v and x, and then I'll be able to integrate. That's the real meaning of using this substitution. Now for dy by dx becomes v plus x dv by dx. Understand why you are using such a substitution. But if you use such a substitution for a non-homogeneous equation, I won't get a split up over here. Remember carefully, this substitution is meaningful only when the function in the right hand side is considered to be identified to be homogeneous, or the given equation is a homogeneous differential equation. I should not use such a substitution for a non-homogeneous equation. It makes no sense. If there is 2 here, there is 1 here, there is 1 here, it's called non-homogeneous. Each term should be of same degree. That's very, very important. Therefore, equation 1 now becomes v plus x dv by dx equal to x plus 7 vx by x. I'm replacing y by vx. X gets cancelled. Take this v to the other side. Bring 1 plus 6v down. Now derivative 1 plus 6v is 6 dv. Therefore multiply and divide by 1 by 6. This is the form dt by t. Therefore 1 by 6 log 1 plus 6v, you can even write modulus if you want, becomes log x. Even everywhere there is logarithmic quantity, I take the constant of integration as log c. Therefore don't cancel log, just equate the values. 1 plus 6 into v becomes y by x. 1 plus 6 into y by x power 1 by 6 equal to xc is the required general solution. I leave the solution with c as it is known as the general solution. Then come to the condition here. When x equal to 2, y equal to 1, or when y equal to 1, x equal to 2. Either way you can write. 1 plus 6 into 1 by 2. Replace y by 1, x by 2. 6 by 2 is nothing but 3. 1 plus 3 is 4. Therefore c now becomes 4 power 1 by 6 by 2. X is replaced by 2 in LHS as well as in RHS. Y is replaced by 1 in LHS. Therefore 1 plus 6 y by x whole power 1 by 6 equal to 4 power 1 by 6 by 2. X, that much times x is the required particular solution. I don't think it is difficult. Every time when I do any problem, I'm just telling you the various possibilities which can be tested in such cases. Therefore remember that here I told you, if it is the form dx by dy, put x equal to dy. Remember such cases, it will be easier for you. Don't learn only the particular problem which is being dealt with. Understand the common rule being expressed, being explained by me in any such problem. It will definitely help you to apply your mind in your board examination easily. The next sum goes like this. Find the vector Cartesian equation to the line passing through 4, 1, 5 and is parallel to I cap minus 2j cap plus 3k cap. Also find the point where this line intersects yz plane, subdivision 1, subdivision 2, the plane x minus y plus 2z equal to 3. Just this is the question, just read the question. Okay, now just see here, equation of line passing through, the point given here is 4, 1, 5 and is parallel to I cap minus 2j cap plus 3k cap is given by x minus 4 by 1, y minus 1 by minus 2 is equal to z minus 5 by 3. The corresponding vector form is R vector is equal to 4i plus j plus 5k plus lambda times I minus 2j plus 3k. This is how you normally write. Where better you write what R vector is. Xi plus yj plus zk is the position vector of general point p x comma y comma z in the line. Remember carefully, better give an explanation for this, but don't forget write R vector equal to is a must. It's a must. Normally I used to get a general point always, but I used to equate it to k or l or either way, but already it is already in terms of lambda. Therefore, general point, you can name it as 1. General point on 1 is, how do you write 4 plus lambda? Then of course 1 minus 2 lambda, then 5 plus 3 lambda. Now first subdivision, where this line intersects the YZ plane. Any point on YZ plane, has x coordinate to be 0. One second, the spelling is wrong. X coordinate to be 0. Therefore here 4 plus lambda is equal to 0 implies lambda is equal to minus 4. The line intersects YZ plane at 0 comma, what is it exactly? 9. 1 plus 8 is 9. Then 5 minus 12 is minus 7. Let it be. Now subdivision 2. Substituting 4 plus lambda, 1 minus 2 lambda, 5 plus 3 lambda in, what is the second equation given? X minus y plus 2z is equal to 3. We get, what do I get? 4 plus lambda minus 1 minus 2 lambda plus twice of 5 plus 3 lambda is equal to 3. Let me just group the constants. 4 minus 1 plus 10. Let me group all lambdas. Lambda plus 2 lambda plus 6 lambda, which will be is equal to 3, which will imply you 9 lambda is equal to 3 minus 13, which is minus 10, which implies lambda is minus 10 by 9. Therefore, the given line intersects x minus y plus 2z is equal to 3 at, just substitute this value, minus 10 by 9 in this place, minus 10 by 9, comma 1 plus 20 by 9, comma 5 minus 30 by 9. That is, after taking LCM, this becomes 26 by 9, this becomes 29 by 9, this becomes 15 by 9. That is the final answer. 26 by 9, 29 by 9, 15 by 9 is the final answer. Let me just check once again whether I have gone wrong elsewhere. Equation of the line passing through this and parallel to this. If it passes through A vector and parallel to B vector, R vector equal to A vector lambda times B vector is the application. This is my vector form, this is my Cartesian form. I used to get it in terms of K or L, already told you, but it's already in terms of lambda. Now for X coordinate will be 4 plus lambda, Y minus 2 lambda, 1 minus 2 lambda, 5 plus 3 lambda. That will be the corresponding general point over here. To identify the point where it intersects the YZ plane and equate the X coordinate to be 0. Any point on YZ plane will have X coordinate to be 0. 4 plus lambda 0 means lambda is minus 4. 0, 1 plus 8 is 9. 5 minus 12 is minus 7. Now similarly, actually people may think you are what is it exactly, plane is not there in syllabus, but here you are going to test only where the line intersects the plane. Therefore it can be tested in your board examination. Only the concept plane and related problems in the examination will not be tested. Here I am going to test where it intersects some other plane. That is always there. Now for substitute the general point here, 4 plus lambda minus 1 plus 2 lambda in brackets plus twice of 5 plus 3 lambda is 3. Now for grouping the constants, 4 minus 1 plus 10, 4 minus 1 plus 10 plus grouping lambdas, I'll get lambda plus 2 lambda plus 6 lambda is 3. Now for 9 lambda is 3 minus 13, which is minus 10. Lambda becomes minus 10 by 9. 4 minus 10 by 9. 1 plus 20 by 9. 5 minus 30 by 9. Taking LCM, 36 minus 10 is 26. 26 by 9. 29 by 9. 15 by 9 is the point where the given line or the line which we obtained intersects the corresponding plane. X minus y plus 2 is equal to 3. This is very well there in the syllabus. If you are tested to find where it intersects the XZ plane, put 1 minus 2 lambda is equal to 0. When it, to find where it intersects the XY plane, equate 5 plus 3 lambda is equal to 0. Accordingly, you should proceed. Anyway, it's already 16 minutes. I'll check for the corrections if there is any. I'll continue the rest in the next video. If there is any correction, I'll add up. Thank you students for patient watching.